So, short lesson today, not very long. There's really only one goal, and that goal is to take polynomials, like the ones that we've been looking at, and dividing them by linear factors, which is going to be important later on in the unit when we're trying to figure out if things factor and how they factor. But here's just kind of a way to review what this means. Okay? Any polynomial, p of x, can always be written as the divisor times the quotient plus the remainder. Okay? And so, I mean, even if we look at a really basic example, like let's say I have 31 and I'm dividing that by 5. Okay, so I know this is not what we're going to be doing, but it'll illustrate the point. Yeah. How many times is 5 going to 31?
6.
Okay. And what's the remainder?
1.
So right here, this 5, that is the divisor. 6, that's the quotient. And this number that's left over, that's the remainder. Okay, the same will work with, polynomials, but what this is telling you is that whatever we're dividing, so the 31, can be written as the divisor times the quotient. So that means 5 times 6 plus the remainder, which in this case was 1. And hopefully that makes sense. Okay? Does that kind of formatting make sense to you guys?
Yeah.
Okay. So now with polynomials, okay, there's 2 ways that you can do division. One is long division. We're not going to do that yet. The other is synthetic, which is actually pretty easy. Okay. This example kind of illustrates it right here. But I'm actually going to just kind of do it on my own here, and then you can have it back here step by step if you need it. Okay. So if we're dividing x cubed plus 2x squared minus 4, and we're dividing that by x minus 3. Okay, the first thing you're going to want to do is take whatever you're dividing by, set it equal to 0. What value do you get for x? 3. So that value, that 3, and I usually use a little box, like a half box, so I know what I'm dividing by. Okay, that little 3 is going to go up here in the corner. That's number 1. Number 2, now you look at your polynomial and you write down the coefficients. You don't have to write out the whole thing, just the coefficients of each term. So the leading term, x cubed, has what coefficient? A 1. X squared has a 2 coefficient. And even if we don't see it, we have to write it down. Do we have an x coefficient? So we're going to use 0 as a placeholder. And then this negative 4, that's just the constant. That's the, you're always going to have a constant term at the very end. Okay, do you guys see where we're getting these numbers from? Okay, and so now here's how it works. To figure out what the quotient and the remainder are, first step, you just bring down this number. Okay, so whatever that number is, you just bring it down. And then now it's just a process that you repeat over and over. You take this number times what you're dividing by. What is that? Write it down underneath the next column. And now you add. We're always adding. So 2 plus 3 is 5, and now you repeat the process. 5 times 3 is 15. Now we add that column again. 0 and 15 add up to 15. 15 and 3 multiply to 45. And now if you add up negative 4 with 45, you get 41. Okay. Do you guys see how we got those values? Okay. So now, here's what this is telling us. And you guys should be able to answer this. If I'm taking x cubed and I'm dividing it by x, what is that going to give us? X to the second, a quadratic. Does that make sense? A cubic divided by a linear is now going to be a quadratic function. Okay? And so this 1 tells me the coefficient of x squared. Does that make sense? This 5 is now the coefficient of the x term. This 15 That's going to be kind of like the minus 4 up here. That's that constant, that number that's just at the end. I'll call it C. And what's 41? That's the remainder, right. Okay. And so if you put things together, I mean, here it is. Here's your quotient, 1x squared plus 5x plus 15. Remainder is 41. Okay? Does that make sense? Yes, question.
So, like, if we were taking a test,
Uh-huh.
what's going to be the final answer?
It depends what it's asking you. I could ask you, what's the quotient, what's the remainder? In which case you would write down, quotient is this, remainder is that.
Yeah.
I could just ask you, what is the remainder when you divide these two? In which case you would just say 41. Does that make sense? It just depends what the question's asking.
Okay.
Yes? So in this top row, that's a good question, you always write down the coefficients for every term. So if you have a degree 3 polynomial, there needs to be a cubic term, a quadratic term. In other words, something to the third, something to the second. We don't have anything to the first. There's no x term, so that's why we have a 0 there. Does that make sense? So in other words, if I had x cubed, and then I just had a minus 4 with nothing else, now I would have another placeholder here. In place of the 2, it'd be a 0. Does that make sense? Okay. Why don't you guys try this one now? 2a. And again, we're just finding the quotient and the remainder. Okay, I'm going to start going through it slowly. You guys can kind of check your steps as I go through it. What number am I going to put here in this little box? Okay. And the coefficients I should use are 1, 0, -6, and 4. Everybody okay with that? Okay. Bring down the first number. And now multiply 1 and 2. 2, add it up. 2. 2 times 2 is 4. Add that up. -2. -2 times 2 is -4. And now we get 0. So what is the quotient? Very good. X squared plus 2x minus 2. And the remainder here is 0. This is actually a very important thing here. Whenever we have a remainder of 0, okay, I want you to think about what that means. That means that this x cubed minus 6x plus 4 can be written as divisor times what? Quotient, good, which is x squared plus 2x minus 2. And since there's no remainder, I don't have anything else to add to it. Does that make sense? So look at what this does. The fact that I have no remainder tells us that x minus 2 is a factor. You guys see how that works? In other words, x minus 2 divides into it perfectly with no remainder. That means that it's a factor of the whole thing. Yes?
So we need the zero within the scenario. Like, where exactly would you put it? Because would it be anywhere before just like anywhere before, just like where it's just solely an x-intercept and not sorry. Like, because the other one, like, it was after 2x squared is where we put the zero, but for this one, we put it after x cubed.
Yes, because, so think about going down in order, right? If the first term, the highest term is to the third, if we just decrease, the next term should be to the second. But there is no term that's x squared. That's why there's a 0 next. You see what I'm saying? Yes?
In that first egg line, the first row, the 1, 0, and then 4.
Yeah.
Where'd you get those?
These are the coefficients of the original polynomial.
So it was the 1.
The 1 means 1x cubed. The 0 means 0x squared because we don't have an x squared term.
Oh, okay.
Negative 6 is the x coefficient. And then positive 4, that's just the number, the constant at the very end.
So if we don't have like either a cube or a 2 or like x,
You would put a 0 in its place. Yes.
okay,
Does that make sense?
yeah.
And so now looking ahead,
I have a question.
yep.
Yeah, when it comes to the 2 on the left, how's that? Shouldn't it be 3 on close to A, but top? Like when the 2 that's like
Right here?
circled, no, on the top. The left side?
The rectangle?
Well, the bottom corner.
This?
Yeah, how'd you get that? 2?
You take whatever you're dividing by and you set it equal to 0.
And you just use that for
Yes. In other words, and you know, this is where this is headed. This value, that's a potential 0 or x-intercept for the polynomial. Do you see what I'm saying? Because if you set it equal to 0 and you got x equals 2, and there's no remainder down here, that means that 2 is a 0 for the polynomial. Okay? But that's only if the remainder is 0. Yes?
How do you know that the x, y, the quotient, how do you know it was x squared?
Because whatever I get here, that tells me the coefficients of the quotient. And so if we have an x cubed polynomial and we're dividing it by something with an x, the very first term has to be x squared, or at least whatever this number is times x squared.
So what if it was the x cubed? Would it just be x?
If what was x cubed?
If it was x squared, would it just be x?
If we were dividing by x squared?
Yeah.
Yes. Then that's a very good question. So now here, well, actually, when you divide, yes, the first term would be x, but we would not do synthetic division with x squareds. We'd only do synthetic division if it's linear factors like x minus a number or x plus a number. Does that make sense? But for instance, if I have something like x squared, in fact, let's say this was x squared minus 6x plus 4. Then my first term will just be x, right? Or if this were a 3 down here, then it'd be 3x. Does that make sense? Okay, so 2 things that you got to know how to do. 1, do the division, translate to what the quotient is and what the remainder is. And number 2, and this is up here in the box if you ever forget, and I would highlight this. If the last number is 0, like we got here in this second example, that means that there's no remainder, and whatever we're dividing by is a factor of the polynomial. Okay? Yes?
So for like A, in that case, the answer is like the quotient.
Yeah, like so this whole thing would be the
Yeah.
answer right here. Quotient is that, remainder is that. Okay? All right. I'm going to go back and do this together with you guys in a few minutes, but let's put it together now. If you can just jump ahead to page 10. So now you can see where this is headed. So let's look at B, okay? So here we have this very large polynomial. What degree is this, by the way? Degree 6, and we're dividing it by a degree 1, right? Degree 6 divided by degree 1 gives us what kind of answer? An x to the 5th, a degree 5. Does that make sense? Okay. And now if we're just seeing, if this, is this a factor? That's the question. Is this a factor? What would I need to get at the very end if this is a factor? 0. Okay. If it gets a 0 remainder, we're good. If we get something besides that, then we would, with confidence, say, no, x plus 4 is not a factor. Okay? So let's check it out. What number would I put in the box here? Good. And then now let's write down the coefficients. There's going to be a few more now. X to the 6th has a 1 coefficient. What's next? 0, because there's no x to the 5th term. And then minus 16. Is there a cube term? So 0 again. 1 for the x squared. Is there an x term? There's no x term either, so we need a placeholder for that. And then negative 16. You guys see how we're getting all those? Okay. And now we just repeat the process. Bring down the first number, which is 1. 1 times negative 4. Negative 4. And now we add. Multiply negative 4 with negative 4 is positive 16. That adds up to 0. 0 times negative 4 is 0. That also adds up to 0. 0 times negative 4 again is 0. Add that up. 1. 1 times negative 4 is negative 4. Add that up. Negative 4. Negative 4 times negative 4 is 16. And look at that. 0 is a remainder. So what do we conclude? So that, yeah, exactly. That x plus 4 is a factor. Okay? And right now, this is just a small little snapshot of what we're building up to. Eventually, we're going to look at a polynomial like this and figure out what all the factors are. But knowing how to get started is a very important step. Okay? Yeah.